Hello, this is Jo from Maths Tutor Me. Today we are doing measurement. Now the lesson today is designed to challenge the people out there who really think they have grasped this topic of measurement and would like a bit of a challenge. The questions that are in here are probably a little bit harder than what you would typically find in a test at this level, but it is good for a challenge for those of you who like to always see just how tricky these questions can get. So let's have a look at question number 1. We want to find the perimeter of this shape. Now, what's tricky about this is that there's so many numbers missing. Now, these little lines mean that they are all the same length. So we know that this one has a number next to it, it's 4. So every time we see that line, it's going to be a 4. Lots and lots of 4s all around this shape. Okay, now what else is missing? We're missing this one here. It will be 10. And we are missing these little side ones here. Okay, what are they going to be? Well, we have 19 the whole way. We could take off 4 from here, which would be down to 15. We know that this is 10 across here, but it comes back 4, which means that this little bit between, this little gap here, would have to be 6, wouldn't it? So there's actually a 4 and a 6 that we'd need to take off that 19, which is 10, isn't it? So we need to take 10 off this 19 to find out that this part here is 9. And that means this one over here, since it's a nice symmetrical shape, will also be 9. Finally, we have this side across the top here that we're missing. It will be a whole bunch of these little things here added together. Well, we've got the 12 across the bottom, and we could add on 4 on this side and another 4 on this side. So 12 plus 4 makes 16, plus another 4 makes 20 across the top. Okay, I think we have all the sides now. So to work out the perimeter, we need to add them all together. Now we have a 20 plus, we have 2 9s here, 9 plus 9, plus, instead of going 4 plus 4 plus 4 so many times, I'm going to say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 4s. I'm going to go 4 times by 10, plus I've also got these 2 10s here, so I could go 10 plus 10, or you could do 10 times 2 there if you liked, and I've also got this 12 across the bottom. Okay, we have all the sides now. Let's use our calculator to add them all together. So we have 20 plus 9 plus 9 plus 4 times 10 plus 10 plus 10 plus 12 equals 110 centimetres. Okay, let's have a look at question 2. It says find the area. Okay, well what shapes can we cut this into? Shapes that we know the area of. If I cut it across here, I have a triangle. We know how to find the area of a triangle. And this shape on the bottom is a trapezium. Now, do I have all the side lengths that I need? Well, the trapezium needs the 2 parallel sides, that one and that one. I have the 17, but I don't have this one here. So I'm going to have to find it. I can add the 17 with the 8. 17 plus 8 is 25 centimetres to get that side there. And I have the perpendicular height. Okay, so I've got the 2 parallel ones and the perpendicular height for my trapezium. Okay, that's good. The triangle, I need the base and the perpendicular height. Now the base of the triangle is just to here. It will be the 17, and the perpendicular height is 9. Alright, so we can find our area now. Area is equal to, let's start with the triangle, it's the nice little one there. So half the base is 17 times the height, which is 9. Half base times height. Plus the trapezium is half h, the h is 10, half h bracket a plus b, where that is the two parallel sides, so 17 plus 25. Okay, there it is. Typing that in the calculator, half times 17 times 9 plus half times 10 times our parallel ones. 286.5 centimeters squared. Alright, let's have a look at question 3. It says we're back to finding perimeter again. Find the perimeter of the kite. Now usually we're asked to find area. We have a formula for area. But for perimeter we need to go around the outside of the shape. Now we would need to know this distance here. So to get that we're going to have to do Pythagoras Theorem with these two shorter sides. It's the hypotenuse, so we're going to be using c squared equals a squared plus b squared. So the 7 and the 12 are the a and the b, so 7 squared plus 12 squared. So what's that? 7 squared plus 12 squared, 193. And then to find the c by itself, I need to square root that. Let's do one decimal place here, 13.9 centimeters. Okay, so that means this one's 13.9. And this one here would actually be the same. It's got the same marking, meaning it's the same length. Okay, we also need to find these two here, which are the same. And we could do that with Pythagoras' theorem with these little sides here, the 6 and the 7. It's also the hypotenuse that we're doing. So c squared equals, this time it'll be 6 squared plus 7 squared. So 6 squared plus 7 squared is 85. Then to get rid of the squared there, we need to square root the 85, which is 9.2 centimeters. So 9.2 here and 9.2 here. So now we have everything we need to find the perimeter. The perimeter we have 13.9 twice, so I can times that by 2, and I have 9.2 twice, times that by 2. My final answer, typing it in. Oops, let me just type that again. 13.9 times 2 plus 9.2 times 2 equals 46.2 centimeters. Okay, let's have a look at question 4. It says, find the capacity of this fish tank in litres. So before we can find the capacity, we have to find the volume. So to find the volume of this rectangular prism, first of all we need to find the area of the cross section here. So it's a rectangle, so A is equal to base times height, so it'll be 38 times 28. So 1064 centimeters squared. Then we can find the volume, which is V is equal to AH. The area was 1064. We times that by the height going back, which was 24. (25,536) centimeters cubed. Now we want to change our volume into capacity. Now centimeters cubed can be changed straight into milliliters. So that's the same as 25,536 millilitres. And then I can change that into litres by dividing by 1,000. So divide 1,000 is 25.536 litres inside that fish tank. Okay, last question here is question 5. We want to find the volume of this shape here. So the volume, I need to find the area of my area, the end here, the cross-sectional area. So I need a base and a height. So they have to be the two sides joined by the right angle. I have the height, that height would be 3.8, but the base I don't have, and I can't use the 4.2 to find the area. I need to find this one here. So we're actually going to have to use Pythagoras Theorem. So to find the shorter side using Pythagoras Theorem, we're going to use b squared equals c squared minus a squared, where we put the hypotenuse in here for c, so that's 4.2. Take away the other the shorter side that we know, which is 3.8. Okay, if we calculate that, 4.2 squared minus 3.8 squared equals 3.2. But that is b squared, remember, we still need to square root that. So b is equal to the square root of 3.2, which will be 1.8 if we go to 1 decimal place. Okay, so this one here is 1.8 centimetres. So now we can find the area. Area is equal to half the base times the height. So half the base we worked out was 1.8, and the height of the triangle is 3.8. So half times 1.8 times 3.8 is 3.42 centimetres squared. Then finally, to find the volume, volume is equal to AH. The area is 3.42. I just need to times that by the height, or the distance going back from the area, which is 6.9. So times by 6.9 equals 23.598 centimetres cubed. There it is. Hopefully you're able to follow all of those examples there, those challenge questions. Well done to you if you did. So that's the end of our topic on measurement. Join me next time and we'll have a brand new topic to look at. Until then, keep practicing. Bye.